Alright, welcome back to Rad Factory 3D. I'm Trace, and I'm the owner-operator of Rad Factory 3D. And I just like to make cool things here. That's really all it is, and I'm trying to make a living off of making my cool things. So a couple cool things I've made. These cool little corner protectors for like refrigerators, appliances, stuff like that. Little bucket for pens. And one of my more advanced designs, I actually have been meaning to make a short about this, because I've already made a part 1 and the part 2 is coming soon. This is a battery powered swamp cooler for your pants, just in case you hadn't seen that one before. I've got a short out there. I'm going to make another one soon about it. But today's video, I just wanted to make a quick one to get back in the swing of things. It's been a little while since I've made a video, and I got myself this cool little sign. I wanted to get back in the swing of things, so I picked it up. And now I realize I have no place to put it. I don't want to keep it on the shelf here, so I'd really like to design a little magnetic shelf to hang over there. I'll show you later across underneath the top rack of my printers. But I'd like to make it removable, so we're going to design a magnetic shelf that you can just set this on and take it off. So let's get started. You noticed I've got a little bit of a new setup here. I moved my office from the other room to this room, so here's a quick look at what that looks like. I'm pretty proud of it. I think we're about to make some magic happen here. So to start things off, I'm kind of gonna go back to the basics a little bit. I'm just gonna use this little piece of paper to take my measurements. By all means, you know, this is my side gig, but I do want to work to professional standards, of course, every time, always. But I'm just gonna use this little piece of paper to start off with to take my measurements. It's just millimeters of the one side, and that's really all we'll need for this project, I think. So to start things off, I mean, I don't need to really go the whole width of the part. So what I'm thinking is just a little shelf to kind of protrudes under more than halfway, but there's only about 1/3 of the width of the whole thing here. So, and then just kind of wraps up the back, comes back over the front, and then it's got a flat surface here that the magnets are going to go on to stick to the front. So that might be a little hard to visualize, but I'll whip it up here in Shapr here in just a minute, and hopefully you'll see what I mean. So looks like the first measurement we're going to want for this is off the center. Will be about 120 millimeters from the center. So 120 width of base. Five millimeters is more than half. If you can see that on there very well. So 5 millimeters is more than half the depth of my lamp. So that's all I'll need for depth of shelf. The height we'll call 95. That'll give 95 millimeters. That'll give me a little bit of clearance to bring the top of the shelf back over the top to come back up here. So now we're really almost done. All I need to decide is how far from the mounting point do I want the lamp to hang, and the depth back under the shelf of where it mounts. But I can't go past too far. I can't go too far past the middle, I think, because I think that will, I think it'll make it want to swing off. So we'll play it safe, and we'll stay right here at the middle. Oh, it's the same as the bottom, right? So 5 millimeters. You know, I like the number 50. We'll do 50 mils up. And we'll do a surface of 30 millimeters for the magnets. Alright. I'm sorry if that was a little hard to follow along with, but now we'll throw this into Shapr, and hopefully y'all can see what I mean. Alright, so sketch us a rectangle. Off of our measurements, we want 120 was our base width by 50. So 20, oh, 20, 50. Alright. Extrude this. It doesn't have to be very thick at all. I think 5 millimeters thick. I think that'll be more than enough. So, add me a construction plane. What I'm going to do is draw me a slightly smaller rectangle off of this one, and we're going to loft that one rectangle all the way up to make our whole backbone of this whole thing, I think. I think that's the fastest and most efficient way to do this. So, that looks centered to me. We'll call that good. Alright. Delete the plane. So what I'm doing here is I'm going through and I'm positioning each one of these rectangles into the alignment that I'd like to make the backbone of my shelf, like I mentioned earlier. Down. So there we go. That's pretty much what we need. So try this. This is just will be an initial test. Operation failed, huh? That's too bad. I think it's because I think the problem is these few here aren't quite in a position to be lofted. Alright, I think this will do us a little better now. So, to select all of our rectangles here. I like it. Better structure, more of what I was going for. I guess there's something I'm doing wrong. Please let me know in the comments. Like I said, I'm an amateur at all of this. So if there's something you think I should be doing better, let me know. I actually have some plans along those lines for in the future. I hope y'all are excited. Oh boy, that ain't enough clearance. Good to know. See? Prototypes. So, Control Z ourselves out of here. I think I've answered my own question here. I think the way to do this geometrically is you loft them one at a time. Yes! Yes! This is what we like. Learning new things every day. I'm sure somebody's laughing at me for not already knowing that, but yep, that's the secret. One at a time or multiples. So now, I noticed that the individually lofted sections are individual bodies. That's okay. We're just going to hit Control All and union these puppies. Nice. Alright. Here we go, making some progress. So I'm just doing a little cleanup work real quick. I noticed some of the geometry was a little funny. So doing this will kind of fix that for us. Boom. Glad I saw this. That's a problem right there. Yeah, that's what we want. Boom. Perfectly parallel surface to put the magnets on. Alright, that's what we like. Okay. Well, that's pretty much it. You need to make magnet holes and then just make the geometry something a little prettier and set her to print. Nice, I like that. So the reason I did that was to help save material, but also to get this underside surface to be a decent angle for printing. So you know, for those of you who don't know, the 45-degree rule. 45-degree angle is the steepest you can go for inclines and not need supports. So, and of course, you know, you want to use as less material as possible. So if you don't have to use supports, don't. And if you're designing your parts, design for minimal support material. So that's what that move was there. And it, you know, it created kind of a sleek design. You know, kind of like old school retro-y type. So I like that. I like that a lot. I'm just going to do a few more details on the geometry, and we're going to set her to print. I'm just gonna add, you know, some personal touches now. So lastly, it's my magnet holes. Now I'm pretty sure that these are 10 millimeters wide. I think I want 3 magnets, just to be sure this thing is going to be strong. Alright, there we're done. So what I did there was, after I extruded the magnet holes in, I just chamfered the edge a little bit just to make inserting the magnets a little easier once the parts are printed. So we're pretty much ready to go here. I'll go ahead and pull this over to Cura. And here's a sliced version I've already got ready. I put the layer height at 0.3 millimeters, ran the infill down, and lowered my wall count down to 3. I usually keep it at 4. This puts print time at 3 hours and 36 minutes. So I think that's pretty good. Oh, I'm silly. You know how we save material here drastically? We sketch under here. Nice, there we go. Some weight reduction there. And you know, kind of got a similar idea, but we'll let's see what this does. All right,
After some minor user error, now I've got my time lapse all set up. We're gonna start this print.
Well, one of them's done at least. Alright, so lastly is our magnets. Oh, nice. Perfect. Alright, there we go. So, it's time for a test. Alright, a moment of truth. Nice and solid. Oh, there we go. Well, there you have it. Nice. We've even got this little mini one with the super lube on. Whew! Alright, well, I mean, that was a lot of fun. I had fun designing this part. I actually had a couple print failures. I've got another one around here somewhere. Here's the first one. Almost done, and it was doing pretty good quality. The first one I printed was pretty rough quality. I did it at that 0.4 millimeter layer height. Too thick. So these are at 0.2, and I realized I had a little problem. That this is just way too thin through here. So as it's printed, this whole thing is wobbling up here, and it broke the whole thing loose. It happened twice in the same section, on the first one and this one. So that was the problem there. And so this one I printed over last night till this morning. And as you can see, I did this down at the 0.2 millimeter layer height. Nice and pretty and shiny. I love that. Magnets in the back. So before I go, I wanted to review a couple of the things that I learned refreshing myself through all of this process. The first thing I realized was with lofting. In Shapr, if you want curved or fluid structures, you loft all your outline shapes all at once. And it took me a few minutes to figure it out, but my goal was a geometric shape with the lofting structure. And I realized the way you get that is lofting your structures individually. So each individual pair, loft them individually, and that'll get you a nice geometric structure on your loft pattern that you like. It took me a little while to get that, and you know, I did that, and I didn't even end up going with that structure, but that's okay. I learned that along the way. The other thing was a swift reminder of thin parts needing more structure. Both those parts breaking off at the same time, just because the top's wobbling too much. So I had to come back, and I made this section just a little bit thicker, a little bit more reinforcement. Which did increase my print time. That was my other goal, was minimal material and minimal print time on this part, but that's okay. And the last thing I learned was swiftly reminded of, was account for shrinkage when you're measuring your holes for fitted holes. So on my little guy, this was the test. I did this at 10 millimeters, and I really had to press that magnet in heavy, and it don't go flush because I made it 3 millimeters exactly. So generally for PLA that I use with my settings, it could be slightly different for you and how you print. Increase your depth and diameter by 0.2 millimeters to offset for the amount of shrinkage for snug press-in fitted holes like these magnets. I did have to put a little glue on these, but for the initial test they'd snap right in and they'd stay for the initial testing. So those are the couple things that I was reminded of and relearned throughout this process. So well, that's pretty much it. If there's something, like I said earlier, I'm an amateur at all this severely, so if there's something that you think I should do better or could do better in my design process, I'd love to hear them. Please put them down in the comments. I appreciate you coming by. Please subscribe, leave a like, and help me grow my little business. Thanks.